Liang and Chun Chun play a game by extending their hands simultaneously to indicate one of the three objects: scissors, paper, stone. Stones in our pool. So scissors will beat paper, paper beats stone, and stone beats scissors, right? It's a famous childhood game. So a player wins a game when the object he indicates beats his opponent. So if the objects indicated are same, the result is a draw, right? So the table shows the probabilities that Liang Liang and Chun Chun and indicates each of the objects in any one game. So the probability of Liang Liang indicating scissors is 0.5. Liang Liang indicate paper is 0.4. Liang Liang indicates stone is 0.1. Okay, so you see it adds up to 1. For Chun Chun, scissors is 0.6. Paper is P, probably, and stone is 0.4 minus P. Right, so find the, in terms of P, the probability that Chun Chun wins the game when Liang Liang does not indicate paper. Right? 最后一题. So this one, right, when Liang Liang does not indicate paper, right? So the thing is we wins the game is what? So for Chun Chun to win the game, could be there are a lot of possibilities. So it means Chun Chun give scissors, Liang Liang give paper, or Chun Chun give stone, Liang Liang give scissors, something like that. So if that's the case, we're thinking it's quite complicated, right? So what can we do? We can try to draw a table of outcomes. Okay, so a simple one could be something like this, and we have maybe 1, 2. Maybe let me. So this will be the total, and maybe I can, in the mean it may differ from person to person, but it's up to you. You choose the format which you like best. Okay, so one is Chun Chun, one is Liang Liang. So for Liang Liang, right, there's a possibility of scissors, there's a possibility of paper, there's a possibility of stone. For Chun Chun as well, there's a possibility of scissors, paper, and stone. So if we talk about Liang Liang and Chun Chun giving the scissors at the same time, so you know, like Liang Liang is 0.5, Chun Chun is 0.6. So it's like this portion here, right, is actually 0.5 times 0.6. So the answer is 0.3. Can you see? So how about paper? So that means Liang Liang giving paper, Chun Chun giving scissors. Liang Liang giving paper, Chun Chun giving scissors. So it's 0.6 times 0.4. So the answer will just come out to be, right, 0.24. So similarly, you can calculate, because they are all actually independent, so the answer will come out quite nicely. So you have 0.5p, but this is the multiplying both probabilities Liang Liang and Chun Chun together, right? And because there's a p later on, you're going to get this, right? This is the table of outcomes that will help you That will help you, okay? So you should be doing this even before you start the question. Otherwise, you're going to have a hard time calculating all the probabilities. You should add up to 1 and 0.6 p and 0.4 minus p. Okay? So this portion actually is the one that we were looking at just now. This is the original Liang Liang and Chun Chun diagram. Right? So part A, we want to find the probability that Chun Chun wins the game, right, provided that Liang does not indicate paper, does not indicate paper. Also, there are a lot of ways we can look at it. So this is just the probability of Chun win and Liang does not indicate paper over the probability that Liang does not indicate paper, right? So what is the probability here that Liang does not indicate paper? So Chun win, Liang does not indicate paper. So Chun win will be what? And Liang. So there are a few outcomes. So you see, if Chun win and Liang does not indicate paper, number one, it could be Chun giving paper and Liang giving stone. So this could be one, right? Another one could be Chun giving stone and Liang giving scissors, right? So the scissors, stone beat scissors ma, and paper beat stone ma. Okay, so Liang, okay, and so there are two possibilities. So the possibility actually, if you think about it, is the possibility of 0.1p. This one is Chun play paper, Liang play stone. Yeah. Then the next one will be 0.2 minus 0.5p. This one will be Chun play stone, Liang play scissors. Chun play stone, Liang play scissors. Okay? Over the probability that Liang does not indicate paper means what? Liang indicates stone or scissors. So if you look at Liang, right? For Liang to indicate does not play paper, so indicate scissors is 0.5. But indicate stone is 0.1. So the answer will be just 0.5 plus 0.1, which is total will be, you can calculate this. Eventually you give 1/3 minus 2p over 3. And that's your answer. Okay? Then for part B, indicate clearly, explain clearly whether the game can be fair for both players. Fair for both players means what? Means we want the probability that Liang wins, right, to be equal to the probability that Chun wins, right? Correct. So what does that mean? It means that we need to really think about all the possibility where Liang win. The probability that Liang win, you see, let's say I use yellow. Maybe I use another color. Maybe I use pink. This one for Liang. For Liang win means what? Could be Liang giving scissors and Liang giving paper and Chun giving stone, right? So it should be this one, correct? For also it could be Liang giving stone and Chun giving scissors, so it could be this one. It can also be Liang giving scissors and Chun giving paper, right? So this one. So you can see a pink color portion. So that means for this one, right? For Liang to win, it's like 0.06 plus 0.5p plus 0.16 minus 0.4p. How about if I want Chun to win? Let's say if I use another color, maybe I use orange. Okay. Probability of Chun to win. Chun to win means, okay, for example, Chun give scissors, Liang will give paper lah. Okay, so 0.24. Okay, if Chun give paper leh, Liang give stone, that is 0.1p, correct? Okay, 0.1p. Then if Chun give stone leh, then Liang give paper, give scissors, then this one will be. So we are looking at 1, 2, and 3. Okay, so answer we want it to be equal to 0.24 plus 0.1p plus 0.2 and 0.5p. So you just simplify this. You're going to get 0.5p equals to 0.22 and p equals to 0.44. So can the game be fair? Let's say you look at p equals to 0.44, right? Then you look at the question, whether does it fulfill all the equation. You can see that straight away, right? The equation that it defies is this one. If p is 0.44, right, this one will become negative. Right, so cannot be. So that's impossible. That means you cannot have a negative probability. So that means we can say that, because Liang, that means you're saying that probably Liang wins is 0.04, which is impossible. So p cannot be a negative number. So the game, therefore, you know that because p cannot be 0.44, right? So the game cannot be fair to both players. So game cannot be fair. Cannot be fair.